right, exponential decay. So the only real difference here is that this time k is going to be negative numbers. So for number 4, oh dear, a radioactive substance has the equation P of T equals 900 e to the negative 0.097 t, where P of T is in pounds and T is in years. How much of the substance was there originally? Okay, so we learned that that's this number out in front. So that's 900 pounds. And the decay constant is that negative number. How much of the substance is left after 10 years? P of 10 equals 900 e to the negative 0.097 times 10. We'll put this in a calculator. (900) e to the 0.097 negative, ooh, that would have been bad, negative 0.097 times 10. Okay, that looks like 341.17 pounds. And I'm going to put a approximation symbol because we approximated. Alright, how long does it take for the substance to reach half of its original weight? So the original weight was 900 pounds. Half of that would be 450. So I'll just do 450 is equal to the equation, and then I'll solve for t. Dividing by 900, I get a half, because I'm looking to figure out when it's half of its original weight, so that makes sense. And then the natural log of both sides. And natural log of e to a power simplifies to just be that power. And then I would divide by negative 0.097. So that gives me that t is equal to natural log of 1/2 divided by negative 0.097. Calculator time. Natural log of 1/2 divided by negative 0.097. Okay, so that looks like 7.15 years. Okay, so I like to think about if this makes sense. So how long does it take for the substance to reach half of its original weight? So we're saying 7 years later it's at 450, and then 10 years later at 341. So that does make sense, I think. It fits with the stuff we already know. Okay, let's keep going. How long does it take for the substance to reach 1/5 of its original weight? So there's kind of a trick here. So originally there's 900. So 900 e to the negative 0.097 t. And then I'm going to set it equal to 1/5 of 900. But then I could just cancel out the 900. So I might as well have just written 1/5 is equal to e to the negative 0.097 t. And then natural log of both sides. And this will simplify to just the exponent. And then I would get t by itself by dividing. Which I will do. Natural log of 1 divided by 5. And then divided by negative 0.097. I get t is equal to 16.59. And this also fits. Goes with my trend. Okay, let's keep going. So a little note here is that half-life is the time it takes for something to decrease down to its half of its original weight. It's exactly what it sounds like. Half-life is the time to become half of what it was. Every radioactive substance has a different half-life. Some substances are like really small, some are really long, and let's just do a couple. So part F says the half-life of this substance is blank. I actually think we just found that. Yeah, how long does it take for this substance to reach half of its original weight? We said 7.15 years. It's nice, we didn't have to do any work. All right, number 5. An unstable radioactive isotope that starts with a mass of 1 kilogram will decay to a mass of 0.1 kilograms in 17 days. What is the decay constant? So it started with a mass of 1 kilogram, so I can start with P of t equals 1 e to the kt. And then I was told that it decays to a mass of 0.1 after 17 days. So e to the k times 17. And be careful, that's a 0.1. So let's see. I didn't really even need to write 1 there. I can just take the natural log of both sides. Natural log of 0.1 is equal to the natural log of e to the 17k. And then this is going to simplify the natural log and e to just be this exponent. So if I get k by itself, I'll just divide. Okay, natural log of 0.1 divided by 17. I get, and I'm going to round to 2 decimals, negative 0.14. So the equation that I'm going to write is P of t is equal to C, which I discovered was 1 kilogram, e to the negative 0.14 t. Pretty cool. What is the half-life of this substance? So originally I have 1 kilogram. Half of that is a half of a kilogram. Take the natural log of both sides because I'm trying to solve for t. So the natural log of e to the negative 0.4 t is just negative 0.14 t. Then I would divide by negative 1.4 and I get t equals natural log of a half divided by negative 0.14. Natural log of 1/2 divided by negative 0.14. So I get 4.95 years. Or actually, I think it's in days. Yep, days. Okay. At what rate is it decaying after 1 day? So P of t is equal to e to the negative 0.14 t. So the derivative is e to the negative 0.14 t times the derivative of the exponent, which is just negative 0.14. And then I want to know what rate it's happening at 1 day, so I just plug in 1. And that is a calculator issue. E to the negative 0.14. And then all of that times negative 0.14. And that is roughly negative 0.12. Okay, so the top of this is going to be, let's see, what is it that we're measuring? Okay, so that would be kilograms a day. So it's losing about negative 0.12 kilograms per day on the 10th, on the first day. Yeah, on the first day. Cool. Let's pause there.